What is up, everybody? This is DJ Friendzone, and today is what I want to do is talk to you guys about power stuff. And there's a lot of misconceptions around regarding power, and I kind of get the impression that there's a lot of DJs who want to know more about power and good practices revolving power. It's just because I've seen a lot of sort of misuse of power stuff, even from some sound companies that don't really know good practices and making irresponsible decisions regarding power. So I'm here to hopefully tell you guys some of the best practices and give you guys some advice regarding power. And I do feel like I have some authority to speak on this subject, given that I am an electrical engineer. And this power stuff, I mean, it should go without saying, but it's super, super important because you don't want there to be any technical hiccups or glitches during your shows, and you definitely don't want to potentially put your customers in any dangerous situation when you're performing. So that's why it's really important to think about power, and that's what I'll be going over today. Now I'm just going to start with the basics here, and the basic kind of thing you'll be working with is this thing called a circuit, which is really just a fancy way of saying loop. And the word circuit comes from the Latin word circuit, which means around. So what's going on with a circuit is you have current that's flowing around a loop and powering all the different devices you have connected to it. Now, what's attached to every circuit, or what should be attached to every circuit, is what's called a breaker or a breaker box. And this does exactly what you'd expect it to do from the name. It breaks the loop or the circuit if the circuit itself is drawing too much current. And you want this to happen because if you're drawing too much current, you'd rather the breaker flip and shut off rather than continue pumping current and potentially start a fire or cause something dangerous to happen. So whenever a breaker flips, it's because you're drawing too much current and it's basically trying to go into protection mode and shut itself down. Now, one thing I will mention is most breakers are going to have multiple circuits on them, and each circuit is generally going to have multiple outlets on them too. So just because you're plugging something into a different outlet doesn't necessarily mean you're plugging it into a different circuit. So you can overload a circuit just the same, you can flip a breaker just the same as plugging two things into two different outlets that are on the same circuit, as opposed to plugging two plugs onto the same outlet or the same extension cord or something. So that's just something to keep in mind. I think some people think like just because it's a different outlet that you're less likely to flip a breaker, and to some extent there is a little bit of truth to that for other reasons, but it's not the same. So just be aware of what your circuits are. Now, one of the ways you can tell if outlets are on the same or different circuits is to just look at numbers at them or look at a circuit map. So if you don't have access to a circuit map, a lot of circuits in residential areas, especially like schools and stuff, will actually have numbers on them. And if they have the same number, that's a pretty good indication that they're going to be on the same circuit. And if they don't have the same number, then that's a pretty good indication that they're not on the same circuit. Now, with that being said, sometimes these circuit maps or especially these outlets can be labeled incorrectly. And as a result, you want to kind of take that information with a grain of salt. And of course, if you're ever in doubt and you really want to check, you can just plug a light into one of the outlets and keep flipping the breakers until you know which one it's on, and then just keep plugging it into the different outlets and checking it. But I never do that. I mean, there's no real reason to do it unless you're really, really concerned that you're going to be flipping a breaker, or you know that you're drawing like a ton of stuff and you want to make sure that everything's on its own different circuits. Now, kind of starting out, most circuits are going to be either rated for 20 amps or 15 amps, and that's basically the amount of current that you can draw before the breaker flips. With that being said, most circuits are only really required to handle 80% of their load for long periods of time. So with that, what that means is a 20 amp circuit is really only capable of delivering like 16 amps for long periods of time, like 8 hours. Now, with that being said, that doesn't mean you always need to use 16 as a hard limit with a 20 amp circuit, especially with things like speakers, because speakers aren't going to be drawing a constant current for a long period of time. But if you're connecting it to the same thing as heaters and other items like ovens, which I don't recommend, but if you have to, that is something to keep in mind, that if you're doing this for a long period of time, even though you may think you're in the range of operating it, you may still flip a breaker over a long period of time. Now, a question I get asked a lot is, how do I tell the difference between a 15 amp circuit and a 20 amp circuit? And the best way to tell is to actually look at the plug. And you can actually take a look here. The 15 amp circuit is your standard plug that you're going to see in your house. It's going to have the two prongs and the little ground hole. And a 20 amp circuit is going to be kind of the same, except one of the prongs holes is going to be T-shaped, which just kind of is a good indication that it's 20 amps. Now, that doesn't always mean that just because you see one of these, you know it's a 15 or a 20 amp circuit. And when in doubt, the best place to check is the breaker box itself, which will tell you what each circuit is rated for. But in general, this is a good rule of thumb. Also be aware, like where you are and where you're plugging things into is going to have an effect on whether you're running a 15 amp circuit or a 20 amp circuit. So most of the places you'll be DJing, whether it's like a wedding venue or a bar, a club, a school, or a business, generally those commercial sorts of areas are going to be rated at, the circuits there are going to be rated at 20 amps, whereas a lot of houses or older places, like older buildings and stuff, are going to be rated at 15 amps. A lot of modern houses are actually moving over to 20 amps, but the way I think it is now with most houses is 20 amps in the kitchen and the bathrooms, and everything else is generally 15 amps. So keep that in mind if you're DJing a house party or something. You may just have to consider that, okay, these circuits are rated for 15 amps, not 20 amps. Now, the amount of stuff you can run on each circuit is going to depend on your load or whatever you're basically putting on the circuit. So in my case, what I'm going to be using as kind of a demonstration are the speakers that I use, which are the JBL SRX series. So right here I have a picture of the JBL SRX 812P. It's a powered 12-inch speaker. And these numbers can be kind of misleading, so bear with me here as I explain what's going on. If I was to just look at what the amp was rated at, which here is in this case is 2000 watts, and I was to divide this by the voltage that's coming out of the wall, which here in the United States is 120 volts, I would end up with an absurdly large number of amps or the amount of current that would be drawn, and I would think that I can only run like one or two of these from a single circuit. The problem is just because the amp's rated at a certain amount doesn't mean that's what it's ever going to be producing or ever going to be producing at a constant level. What makes a lot more sense to look at is what's called the 1/8 power rating, or potentially even the 1/3 power rating, and I'll talk about why manufacturers use these numbers and where to find them. So if I'm here at JBL and I'm looking at the SRX 812P, generally what you're going to want to do is look for the spec sheet. So if I click here and I open up the spec sheet, I can look down here at the specifications, and lo and behold, I have these AC power consumptions at 120 volts because I'm in the United States, and it's giving me two numbers. It's giving me 2.2 amps for 1/8 power and 5.6 amps for 1/3 power. And you guys are probably thinking, well, Friendzone, gee, like why are they telling me 1/8 power? Why should I care? Actually, 1/8 power is perhaps one of the most useful numbers that you're going to have, because what 1/8 power means is this is the amount of amps that your speaker is pulling when you are driving it pretty hard with music. And by pretty hard, I mean your chances are you're touching the limiting light every once in a while, or even pretty constantly, but there's not really any audible distortion. So for me, I generally don't like running my speakers into the limit light at all. Switching over to the JBL SRX series from other series has kind of changed my mind, because these do end up limiting pretty early, just because of the way they're designed. But even then, I mean, I don't think I would ever be in danger of getting anywhere close to this 5.6 amps, which is 1/3 power. So the way to think about it is the 1/8 power, that's generally a clean signal coming out, the loudest you can get with a clean signal. 1/3 power is going to be very, very heavy limiting applied, potentially even some like distortion and stuff. Your limit lights are going to be going nuts, and you're never, ever, ever going to be running this at its full ampage or whatever it's going to be at full, which would, I guess in this case, be around 15 amps. So you never really have to worry about getting close to that, but do keep in mind this number. So if I'm running a 20 amp circuit and this is rated at 2.2 amps, I can easily run, let's say 5 of these speakers without a problem and on a single circuit and not have to worry about anything. Now, with that being said, connecting it with lights and other apparatuses that are on the same circuit will change that and will draw some current as well. But with these Class D amplifiers, which are in a lot of these powered speakers nowadays, they're actually surprisingly efficient, and you generally don't have to worry too much about drawing too much current from just running them. If you are ever in doubt about how much current you're drawing, or just want to make sure that you're never getting close, or just you want to measure how much power your whole setup is drawing before you're actually performing live and having to worry about a crowd and all that stuff, you can go over to Home Depot or some other hardware store and pick up one of these things called a kilowatt electricity monitor. And these things are pretty cool. There are a lot of different types. You don't have to just get this one. This is just the one that I know a lot of DJs that I've talked to use. And you plug this thing in, and it basically just tells you how much power you're drawing and what's actually going on. So it'll tell you the voltage coming out the wall and how much current is actually being pulled by your entire system if it's coming out of one outlet. And this can be really helpful because you can test your individual components and you can test your whole system. And I guarantee it's not just going to be like, oh, adding up the individual components, because you put everything on the same circuit, there's going to be all sorts of other things. You're using longer extension cords, there's going to be like voltage drops over the extension cords and all sorts of other things. So it's important to just keep that in mind. And just having a meter and knowing what's actually going on can be really, really helpful. So I would definitely pick this up. It's like 20 bucks and you can monitor it with your whole setup or different setups. So that's all that I have planned for this video. I actually plan on talking about a lot more, so including some best practices, but I'm actually going to split this up into two parts, or actually multiple parts. And in the next video, I'll be talking about best practices regarding power, specifically wiring things up and what to consider. So more like practical tips, whereas this was kind of more of a background. And if you guys have any suggestions or any ideas for other videos or anything you want to learn about, leave a comment or send me a message or something and I'll do my best to accommodate those. Once again, thank you guys for watching. If you don't mind, hit that like button, hit that subscribe button, show some support so that way other DJs can find this video and can find out better practices with power as well. All right, Friendzone out. See you guys.